Hey math enthusiast, I'm here to review the answers for the 10.4 practice on inscribed angles and polygons. First couple were pretty straightforward. You're just looking for either an angle or an arc measure. For this first one, I'm worried about arc ST up here on top of my circle. So the only information I'm given is this inscribed angle, 61, which tells me that the intercepted arc, TU, is going to be double that amount, which gives me 122. The other thing that I noticed here is that SU is a diameter, which means that arc SU is a semicircle, so it adds up to 180. So from there I can do 180 minus the 122, which leaves me with 58 for arc ST. For this next problem, now I'm worried about the measure of angle A. I can tell it's an inscribed angle. It opens up to this intercepted arc, BC. So if I can figure out arc BC, I'll be able to get the measure of angle A. Well, I know arc AB is 54, and obviously AC is a diameter, which means that arc AC is a semicircle, similar to the last problem. So all I really have to do is 180 minus that 54, which leaves me with 126. But remember, that represents the arc measure. So that's arc BC. What I'm looking for is the measure of angle A, which is just going to be half of that arc measure, which is going to leave me with 63. Next problem, I'm looking for arc VST, so V to S to T. I already have 39, which is part of that arc, but I'm going to need ST if I want to figure out the rest. Okay, so let's focus on what we actually do have. So I have this arc over here, TU, which is 135. And then this arc right here, VU, is the intercepted arc from this inscribed angle. So I know it's going to be 102 degrees, double that 51. Well, at this point, I almost have all my arcs around the circle. 135, 102, 39. The only piece I'm missing is this one up here. Well, I know all the way around my circle is 360. So let's take out all the arcs that I do have. So we'll take out the 135, I'm going to take out the 102, I'm going to take out 39, and I'm left with 84. So now I know this little arc ST is 84. Well, remember, they want V to S to T. So it has to be the 39 and the 84 together, which is going to give me 123. Last problem from this set, I'm looking for an angle measure. I'm looking for the measure of angle K. It's an inscribed angle, and it opens up to this intercepted arc. Well, it looks like angle L is also an inscribed angle. It's 28 degrees, and it opens up to the same intercepted arc. So right there, I know angle K has to be 28 degrees. Now, for this next problem, I'm focused on circle P over at the right. They give me some information. This should be arc LM and arc KN are 84 degrees and 116. First thing I want to focus on is just the picture on the right. Don't worry about all the questions over here on the left. Okay, what I want to focus on is just filling in everything I can on this picture over here on the right. So let's get started. So the first thing I know is this arc right here, LM, which they tell me is 84. So let's just focus on that right now. Well, this intercepted arc, LM, opens up to this inscribed angle, which would therefore be 42, half of the intercepted arc. It also opens up to this inscribed angle, which would have to be 42. Okay, let's see what else we can fill in using this 84 alone. Okay, well, it looks like JL is a diameter in my circle, so therefore I know that arc JL is a semicircle, which tells me this arc over here on the left is going to be 96. I'm not sure if that's going to help me yet, but we'll put it down. The other thing I notice is that since this is a diameter and this is a semicircle, the inscribed angle that opens up to that would be this one right here, which tells me right away that this has to be 90 degrees. Now, if that's 90 degrees, It means that if the right side is 42, this side on the left has to be 48. Now, the only other thing they gave me is the fact that Kn, which is this whole arc that I'm highlighting in green, was 116. Now, the inscribed angle that opens up to that would be this one right here. All right, so this whole one, which would be half of 116, which gives me 58. And you also have another inscribed angle. You have this one down here, which would also be 58. Okay, so I have a lot of stuff filled into my picture so far. So let's clean this up. Now, once you have all that filled in, it should be easy to go back and answer all the questions that they're asking. So let's see what they actually wanted. So the first thing they want, JKL, I already filled that in. We knew that was 90 degrees because of the diameter. Next thing, MJ, I filled that in. We knew it was 96 because of the semicircle. MKL, I filled that one in because it was the intercepted angle that opens up to 84. KMN is the next one I'm looking for. We filled that in already. It was an inscribed angle, 58. JKM, which was 48 because it was part of the right angle up there. Arc LKJ, L to K to J. I didn't fill that one in, but I do know because of that diameter in there, right here, that L to K to J has to be a semicircle. So I know it's going to be 180. Next one, KLN, 58. We filled that one in because it was an inscribed angle. And the last one, LNM, find that in our picture, it was 42 degrees. That's it. Now, for the next set of problems, there was a little bit more work involved. I'm actually trying to solve for a variable in these cases. So they give me an inscribed angle, angle A, which is 5x, opens up to the intercepted arc, 9x plus 21. Now, I know these two are not going to be equal, but I'm trying to figure out how can I set these two expressions equal to each other. Well, remember, you have to double that inscribed angle measure to get it equal to the arc measure. So that's exactly what I'm going to do to get started. So it's really going to be 10x equal to 9x plus 21, which is obviously going to leave me with x equals 21. Now, I just want to run through and double check to make sure this is correct. So I'm going to have 105 for the inscribed angle, and then 210 for the arc. So it looks like it works out. My inscribed angle is actually half the measure of my intercepted arc. For the next problem, I have an inscribed quadrilateral, so I know I'm going to be applying the inscribed quadrilateral theorem. So if you remember from that theorem, what it tells me is that the opposite angles, so like angle M and angle K, are supplementary. They're going to add up to 180 degrees. So I know I'm going to have 2y plus 104 equal to 180, which is going to give me 2y equals 76. Last thing I'm going to do is divide by 2, which gives me 38 for y. But we also have to solve for x. So I have 5x here, 110 here. I'm going to do the same thing for this equation. So I'm going to have 5x plus 110 equals 180. So 5x equals 70. X equals 14. Next problem is very similar to the last one. Once again, I'm using the inscribed quadrilateral theorem. I know that these opposite angles are supplementary. I know they're going to add up to 180. So I'm going to add up these two expressions, set them equal to 180. Well, it looks like I have 3x and 5x, which is going to give me 8x. I have negative 8 and positive 2, which is going to give me negative 6. So I end up with 8x equals 186. X equals 23.25. Now, for the next problem, we're once again given an inscribed quadrilateral. Well, according to my theorem, I know the opposite angles are going to be supplementary. The problem is I don't have this angle measure up here. But I do notice that this inscribed angle, this 4x, opens up to this arc. All right, and for my other variable, this 7y, this inscribed angle opens up to this arc. All right, well, both of them cover arc AB. So I'm really going to need to find that piece first. So the arcs that I have, 84, 80, 152, I know all of them are going to add up to 360. So let's take out all the pieces I do have. The 152, the 84, and the 80, which is 44. So I know that this arc measure up here is 44. So let's start with the 4x. This inscribed angle opens up to this whole arc here, which is going to be 84 and 44, which together is going to give me 128. Now, I know this inscribed angle, this 4x, it's not going to be equal to 128. It's going to be equal to half of that intercepted arc measure, which is going to be 64. So now when I divide by 4, I know x is going to be 16. So to solve for y, now I'm focused on this inscribed angle. Well, this one opens up to arc ABC, which is going to be the 152 plus the 44. Which gives me 196. So, similar to the last problem, I have 7y. It's not going to be equal to 196. It's going to be equal to half that amount, which is going to leave me with 14. Now, for the next problem, there's only one variable. So all my expressions only include y, but the first thing I notice is this y squared. So it's probably going to be a little bit harder than the previous problems. Now, focus on the theorem given. It's an inscribed quadrilateral. So once again, I know that opposite angles are going to be supplementary. Well, I don't have angle U, so that really doesn't help me. So I can't do much with this 5y plus 7 right now. So what I want to focus on is the y squared plus 31 and the 8y minus 4. I know that those two expressions together are going to add up to 180. Those angles are supplementary. So let's combine some like terms. I got y squared, put it in standard form as well, which gives me positive 27 equals 180. So right now at this point, because I have a y squared, because I have a y to the first, and I have a constant here, I know I'm going to have to factor. So I'm going to start off, I'm going to get rid of this 180 from both sides. All right, if I'm ever going to factor, I need my expression equal to 0. -153. So now what I'm focused on is the 8 and that -153. I know my setup is going to be y and y for my first terms, and I'm looking for factors of 153 that are going to add to positive 8. Well, 17 and 9 are factors of 153. It's got to give me positive 8, so I'm going to make the 17 positive and the 9 negative. So my final answers for y are going to be -17 and positive 9. All right, now, once again, I have to check these answers. So let's go back to our pictures. So if I do try to plug in -17 into these expressions, I'm only going to get a negative angle measure. So it looks like my only solution is going to be y equals 9. So let's just plug that in and double check to see if it works. So I'd have 81 plus 31, which gives me 112, and then I'd have 72 minus 4, which gives me 68. So these two angles, opposite angles, they should be supplementary. They should add up to 180, and they do. For the final problem in this practice, it looks like this expression, the 9x minus 4, represents a central angle opening up to this arc. The 4x plus 2 is this inscribed angle opening up to this intercepted arc. Now, you have to remember the relationship between these two. All right, if this angle, let's say, for example, was 50 degrees, then I would know that this arc is 50 degrees. But that means that the inscribed angle over here would be half the arc measure. So try to use that example to set up an equation between these two expressions. They're not going to be equal, but I want to make them equal by changing one of them. Well, based on the numbers I used, if I wanted that 9x minus 4, that central angle, to be equal to the inscribed angle, I would have to double that inscribed angle. Once you have your equation set up, now we just got to go through and solve. 8x plus 4, x equals 8. Now, if x equals 8, my central angle here is going to be 68, and my inscribed angle over here is going to be 34.